Hi everyone, today we're going to start about actually solving quadratic equations. So everything that we have done this 6 weeks up to this point has been leading up to this. So when we talk about solving a quadratic equation, so far we have just been dealing with quadratic expressions, ax squared plus bx plus c. But if it's an equation, it has to have an equal sign, so y is equal to all of that. In order to solve a quadratic equation, we are going to take what we have and set y equal to 0. So this is what we're actually going to solve. Ax squared plus bx plus c is equal to 0. Our solutions can be called many things. Sometimes they are called roots because they are the roots when we take a square root of something. They can also be called the zeros because we've set an equation equal to 0. They can be called x-intercepts because that's what they are when they are real solutions. They're the spots on a graph where the graph crosses the x-axis. And finally, we can just call them solutions. The other thing that you should notice is this horizontal line. And this is just to remind you that we are talking about the horizontal or the x-axis, because we're looking for where does the graph cross the x-axis. This entire graphic should look familiar to you from Algebra 1. One technique that we'll use to solve quadratic equations is to solve them by factoring. So we will factor like we learned to do with the Xbox method, and then we'll solve for x by setting each expression equal to 0. So let's go ahead and take a look at an example. So this example says that 3x squared is equal to negative 15x plus 72. Notice that right away I can see that this is not in standard form. In order to solve this in standard form, I need ax squared plus bx plus c is equal to 0. So I need to move the things that are on the right over to the left. So let's go ahead and do that. I'm going to add 15x to both sides. And I'm also going to subtract 72 from both sides. That will make these cancel on this side and put everything on the left-hand side like I want it. So 3x squared plus 15x minus 72 is equal to 0. Remember that our first step in factoring is to look for a greatest common factor, and I see that there is a 3 that I can pull out of each of the terms on the left. When I do that, then I need to write what I have left over, and that will be 3 times x squared plus 5x minus 24. And again, the new thing is setting it equal to 0 so that we can solve. Now that I've done that, I can identify my a, b, and c terms, a, b, and c, and set up my x puzzle. Remember, it's a times c in the top and b in the bottom. So I have a 1 times a negative 24, a times c is going to give me negative 24, and my b value is 5. So I'm looking for factors of negative 24 that add to be a positive 5. So that means that I need a positive and a negative sign on my factors, and the bigger factor must be positive because of the positive 5. All right, let's go ahead and start. I have a factor of 1 and 24. The 1 is negative. Negative 2 and 12, negative 3 and 8, negative 4 and 6. Looking down the list of these factors, I can see that negative 3 and 8 are going to give me the 5 that I need them to add up to be. So negative 3 plus 8 is 5. So those are the factors I'm going to use, negative 3 and 8. Let's go ahead and set up our box now. I know that I need my ax squared term in the upper left, and that's just going to be x squared. I need my c term in the lower right, and then I'm going to fill in with my factors times x. So I'm going to have negative 3x and 8x. And now I just need to find the GCF across each row and down each column. The GCF, or greatest common factor, between x squared and 8x is going to be an x. Between negative 3x and negative 24 will be negative 3. don't forget that if you have a negative sign in the box that's right next to where you're writing, you need to put that negative sign there. If it's positive, then you leave it as positive. X squared and negative 3x have an x in common. 8x and negative 24 have an 8 in common. And I can go ahead and write the factored form of my quadratic. I still have the 3 that I pulled out as a greatest common factor, and now I can write my factors as x minus 3 and x with a plus 8. So x minus 3 and x plus 8, and remember I'm setting that equal to 0. So now what I want to do is I want to solve for x. Here's what we're going to do in order to do that. First thing I want to do is I want to get rid of the 3 that's out in front. And so in order to get rid of a 3 that's being multiplied on each side, I can divide it. So when I divide this 3 on the left, that's going to cancel to 1. On the right, I have 0 over 3. Well, what is 0 divided by anything? It's still 0. It doesn't really make a difference. And so I really just still have a 0 over here. Now we're going to use something called the zero product property. The zero product property says that if you have two things that multiply together to be 0, then one of those things has to be equal to 0. Either A is equal to 0 or B is equal to 0. So we are going to use this and say that either x minus 3 has to be equal to 0 or x plus 8 has to be equal to 0. So let's do both cases. Case number 1, x minus 3 is equal to 0. Case number 2, x plus 8 is equal to 0. Now I just need to go ahead and solve these two small algebra equations. I'm going to add 3 to both sides so that the 3's cancel, leaving me with x is equal to 3, and that's one of my solutions. I can subtract 8 from both sides. The 8's will cancel. 8 minus 8 is 0, and x is left to be -8. This is my other solution, and I have solved my quadratic.